Welcome everyone to Physics 170. This is the online version of the specific heat and latent heat experiment. Now at the microscopic level, temperature is the motion of atoms or molecules. In gases and liquids, atoms are actually free to move around, whereas in solids, they just vibrate or oscillate about their equilibrium position. The hotter it is, the faster they move. Now, if you have two substances initially separated, like the two gases here by that green dividing wall, on the left-hand side, the atoms are moving fast. That's because this gas or liquid is hot. On the right-hand side, the atoms are moving much slower because the temperature is low. But once we move the divider out of the way, the faster atoms now collide with the slower atoms and transfer their energy. And after a while, all atoms have more or less the same average amount of energy. That's when we have a thermal equilibrium. So here is a simulation of the experiment we're about to do. On the left-hand side, we have a hot metal block. On the right-hand side, we have water at approximately room temperature, 20 degrees Celsius. And we will now transfer that hot metal block into the room temperature water and look at the temperature of the water. That's the solid black line, and you see the water is warming up, the metal is cooling down, and that's because the fast vibrating atoms of the metal transfer their energy to the water molecules. So here we have a metal block that I will dump into a beaker that's sitting on a hot plate, and as you see, the temperature is still rising. In the meantime, we will fill a styrofoam cup with water, and it's on a scale. We'll fill it with exactly 123 grams of cold water. Let me move the temperature probe over and see what the temperature of the cold water is. We'll take half a minute or so for that probe to get into thermal equilibrium with the water. All right, let's transfer the metal block to the cold water. Here we go. And I'm using the temperature probe to stir a little bit so that the water will get into thermal equilibrium faster. And finally, we weigh our metal block and find a mass of 89 grams. All right, so in the meantime, I've replaced the first metal block with a second one. You see, it's bigger, it's also a lot heavier, and it's been sitting in the boiling water for a few minutes, so we can assume that it's at 100 degrees Celsius. And here we have our cold water again. Let's transfer the block over to the cold water. Let's keep stirring and see what happens. So you see the temperature of the cold water is rising up to the point where we reach an equilibrium. That's our final temperature.